I've gone back and forth between focusing on development and focusing on data and enterprise concerns. But probably for this talk, one of the key things to talk about, I guess, is the fact that I'm the person behind the Agile data method. And in the very early days of Agile, we realized, a bunch of us got together and at one of the Agile conferences, and we started talking about, well, if we can't do this data stuff in an Agile manner, then Agile was going to fall apart. And so we started identifying basic what you would think are basic techniques like database refactoring and database testing and good stuff like that and figuring it out. But what was interesting is the next 10 years, so this was early 2000s, in the next 10 years, that material was pretty much ignored. And the data community kept being the data community, and they were slow and ineffective and doing very low quality work, spinning stories about how it wasn't their fault, the garbage they were producing, everybody else's fault but theirs, usual data guy stuff. But now, in the last 10 or 15 years, it's really taken off, and particularly in the last 2 or 3 years, we're seeing just this exponential growth mostly because of AI, I think, and a little bit about data warehousing, but just in the acceptance and adoption of what Agilists would consider fairly standard techniques now, but are still sort of radical for the data community. I'll talk a little bit about that as well. So I'm glad to see that happening. So what do I want to talk about today? I'm going to get it. Excuse me. I'm going to very briefly talk about what AI is, but we've all been hearing this. But it's good to have some definitions because I think a lot of terminology gets thrown around, and it's not quite clear what people are talking about when they're talking about AI. But for the most part, I'm going to focus on machine learning, which is a very important subset of AI, and this is where the action is in corporate America, or at least where it will be. Like, people are playing around with large language models now because you can do some really cool stuff with it, but that's not all that interesting in my mind. Yes, you can do cool things, and I really like the cool things. I'm a new toy kind of a guy. But real corporate mission-critical AI will be machine learning stuff, not this LLM goofball stuff, right? So anyways, we'll see, but there's a place for that, don't get me wrong. Then we'll talk about data quality and talk a little bit about some of my thesis work. I recently completed a master's degree in AI and with a focus on the effects of data quality on AI. And basically the short story is garbage in, garbage out, exactly what you would think. And I got some numbers on that. I'm not going to share the numbers because it's just too detailed. And then finally, I'm going to get into, well, how do we actually address data quality? Because for those of you who are doing AI or working with data scientists, one of the challenges with data scientists is they like to complain about how they spend 80% of their time doing data cleansing, and then the other 20% of the time complaining about doing data cleansing. These are very highly paid and highly skilled people, and they're wasting a lot of effort doing this data cleansing stuff. Now, it's not quite 80% of their time, but claiming that 60 or 70% of their time wouldn't be far off. So there's a huge opportunity to get our act together. And I'll share some industry stats on why we desperately need to get our act together on this. Data quality is the #1 or #2 showstopper right now for most organizations doing AI. So it's fairly important. So data quality it might be the most important success factor in AI. It's certainly in the top 5, without a doubt, and it tends to be a showstopper for most companies. The best place to address data quality is at the source. Fix the source. Everything else is a waste of time. Common industry practice right now is to do exactly the wrong thing, fixing at the point of usage rather than the actual source. It is grossly incompetent. When I speak at data conferences, I talk about firing every single person in the room because they are the problem. They're convinced it can't be done, and there's wonderful excuses, whine, 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 whine. But at the end of the day, none of the excuses hold water. So we'll talk about that. And now one of the challenges, to be fair, is that the situation that you face will drive your choice of data quality techniques. You know, use the right tool for the job type logic. Well, how do you understand what situation you're in? And that's something that a lot of the practices people, the methodology people never talk about. This is a serious problem. It has been a serious problem for decades and will continue to be a serious problem. The people who tell you about new practices, like the Scrum practices, for example, like daily stand-ups and all that good sort of stuff, or techie practices like refactoring or testing or whatever, they tell you how awesome it is. They always tell you about the benefits, how it'll save it'll save democracy as we know it. There's always a wonderful story for why it's awesome, and that story is generally true. But they never tell you what the downfalls are. What is the side effect of doing daily stand-up meetings? What is the side effect of refactoring, right? Because there's always a downside. And as practitioners, we need to choose the right techniques for the situation that we face. And the only way that we can do that is if we know, well, this type of a practice, this type of a strategy has these benefits, but it also has these problems. So if I adopt this strategy for these benefits, I got to counteract it. I got to do something to counteract these problems then, or learn to live with these problems, right? And then you need to come up with the right mix of strategies that address whatever issue you're trying to address, right? So there's a lot of opportunities. The other day when I was talking about how I'm in the process of updating my own work, some of that update work is to put contextual information around the practices that I describe at my site. Or sites, I should say. But be that as it may. So what's this artificial intelligence stuff? Very quick definitions. And my last name is not Webster, so don't expect an exact definition out of me. That is not my job. But anyways, so AI, it's computer systems. Notice how I'm using our computer to perform tasks normally requiring human intelligence. Machine learning is AI, so it's a subset of AI. It's not just about machine learning. There's other non-machine learning stuff going on in the AI world. But it often involves the training and creation of models without explicit programming. So for example, a non-ML version of AI would be a rules engine or an expert system. Those are generally coded, right? So you got to program those AIs. That's hard. So for the last 20 years or so, there's been this category of AI called machine learning, where we just basically pump a bunch of data into it and we spew out a model. You know, magic occurs. And I shouldn't say magic, it's very significantly complex mathematics occurs, right? It just appears to be magic for those of us who don't have PhDs in math. And that was part of my master's work, was learning the math. I didn't have a lot of fun doing that. I had to relearn the math that I used to know. Deep learning is a subset of ML where the models that are being created have what we call neurons. Now, it's not exactly the type of neurons we have in the brain. So it's this synthetic neurons might be a better way of looking at it. Often called artificial neural networks, ANNs or ANs. And then finally, the thing that we're all probably familiar with and have been completely and utterly overwhelmed with the last couple of years are LLMs, large language models. And that's a form of ANN typically based on transformers or tensors. And that's all okay. Now, and they tend to be created based on large amounts of data, most of which is stolen data. So there's some very interesting ethical issues going on right now in the industry. So be very careful with what you do and what you publish. Okay, so, excuse me. A big topic that I want to talk about is the machine learning lifecycle. How do we develop these AIs? And to be fair, the life cycles I'm going to show you are very applicable to non-ML AIs as well, but that's not my space. So I don't want, there are some important nuances in the non-ML world that I don't want to go into. So anyways, let's focus on the stuff we're doing. If you read the literature, you'll often hear people, when people talk about the ML life cycle, the development life cycle, they tend to talk about this. There's this period of time where we train the AI, and then there's this period of time where we operate the AI in production, making inferences and predictions and good stuff like that. And then we rinse and repeat. There's a feedback cycle, right? And it's amazing, in most of the books, this is what they talk about. Actually, most of the books just talk about this, and then it's, oh yeah, by the way, we also run them eventually. So serious lack of detail. So bringing in some detail, so we start thinking about what are the types of things that happen in construction? Well, we got to choose a training strategy. So there's dozens of types of models that we could create. LLMs, large language models, being one type of several dozen. So depending on the problem that you have, you've got to choose what type of model I want to build, right? Again, you got to hopefully choose right. And if you don't, well, things happen, and we'll talk about that. And then you got to prepare the data, do some data cleansing, train the model, validate the model, deploy it at some point, right? So slightly more detailed version of the model sort of looks like waterfall, which might be, but it's interesting that when you do read some of the literature, this is this type of level you'll often see as well, where if they start talking about what training looks like, it gets communicated like this. But in reality, it looks a lot more like this, because these three activities here are very iterative. Like, you generally start with choosing one or more types of models you want to create, hopefully get it right. You build some stuff. You might discover through validation, through testing, that, ooh, wrong freaking model, we're not getting the results we wanted, so you got to rethink the model, right? So maybe, I chose decision trees, and then, oh, random forest might have been the way to go, or oh, SGD might have been the way to go, right? So I just guessed wrong, right? So, because it is a skill, there's some inherent experience going on there. And then we still need to deploy the AI. Now this, right now, I'm showing as a phase, because the first time that you develop something, the deployment tends to be pretty rough. It tends to be reasonably manual. Yeah, you might have scripts, but humans are involved running it, right? It's not a fully automated DevOps thing yet, right? So, and deployment is interesting. For example, I got some very important decisions that have to be made earlier. Do I deploy to the cloud? Do I deploy on-prem? Am I deploying to an edge device, like a laptop or a phone? Combinations thereof, right? So there's some very significant deployment decisions. There's also, depending on the nature of what it is that you're automating, how many models need to be deployed. So for example, I was involved with an insurance fraud system a while back. This was an insurance company, well, it was across North America, but it had some stuff going on in Europe as well. And the reality was that one model did not fit all. It was an automotive accident fraud detection, basically. And the challenge is that, well, first of all, the laws in different parts of North America are different, like at the state and province level. Sometimes at the city level, different bylaws. Certainly the legal laws, like what you can get away with, vary as well by state. So what would be fraud in one state might be okay in another state. Not really, but there's some nuances, right? What can you get them on is an issue at some point sometimes. But the driving habits in different parts of the world are different, right? The people in Toronto drive differently than the people in Tucson, Arizona, who drive differently than the people in Bangalore, right? So you have different types of accidents. You have different cultures in each of those cities. The way that a Torontonian is going to commit insurance fraud is different than the way that a New Yorker will try to commit insurance fraud, right? And the models have to reflect this. So stuff happens. So anyways, long story short, I might be deploying multiple models into multiple environments for whatever good reason. So deployment is not as easy as it sounds sometimes. And then of course, there probably should have been some upfront work. The AI community right now enjoys like a 70 or 80% failure rate. Most of the AI projects probably should never have even been started. So you should be doing a little bit of upfront thinking of, like what business processes are we trying to augment? What data do we need? Do we have the data? There's an important question to be asking. Do we have the actual data? And not like just fantasy world, oh yeah, we got a bunch of data, but it's like, well, what type of data do we think we need? Is it any good? What do we know about it? And those are gut check reality questions you should be asking up front. Now what generally happens is you'll think, oh yeah, we know the data's sort of crappy, but we can live with it. And then you get into hot and heavy into construction, you start digging down into the details, and it's a freaking mess. Right? It's like, for those of you who work with legacy code, legacy code is always pretty clean until you open the file and look at it. And then it's a mess, right? Same thing with legacy data. Always sounds pretty clean when you're looking at bubbles connected by lines, but when you dig down into the actual tables and see what's being stored, yikes. So anyways, stuff happens. We'll talk about that as well. So you should be, doing some basic viability questioning here. Because more than likely the answer is no, this is a really bad idea. More than likely. But we still enjoy an 80% failure rate. So this is more of a project type of a life cycle. And it's not really a project life cycle because we have feedback cycles here, right? We go on to next versions. So AIs are products, they're not projects. So if you're fighting these battles in your organization still, we got to fund everything like a project, tell the project manager just to go away, fetch me a coffee. There's some important management stuff that needs to occur, don't get me wrong, but injecting a project on top of an IT effort, let alone an AI effort, is just a sucker's game. Why would you take on that cost and risk just to make some project managers feel good about themselves? I don't think that's very important. So we got more important things to worry about than what project managers think. So anyways, so if you're more of a DevOpsy type of a person like me, or a continuous delivery type of a person, I guess you'd say, just trust me. The activities we saw on the previous slide, that's how you would map them to a more of a DevOps life cycle. And this is the reality, or I should say an ML, machine learning ops life cycle. You always got to change the name of DevOps. But anyways, this is the reality. If you're successful at developing these AIs, this is the situation you're going to find yourself in. You'll build something, get it out the door, update it, get it out the door, update it, get it out the door, and so on. You might be deploying several times a day, like updates to your models several times a day. It depends on the nature of your domain. You might be deploying, like in the insurance world, we were deploying a new model once a quarter because people weren't coming up with new ways to scam us that fast. They were, but not as fast as other domains. If you're familiar with data science at all, this is the classic DM lifecycle, the crisp DM lifecycle. I like to show that once again, this is more of a iterative life cycle than what the crisp people like to show. Microsoft has a fantastically good rendering of this. So if you're a life cycle aficionado, then go look at what Microsoft does. They bring people into this, and they've got a graphic artist. This is the extent of my artistic capability, these bubbles and lines. So be that as it may. So the point is, different ways to look at the machine learning life cycle. And this is still fairly high level, right? Well, what the heck does this train, what the heck is trained model, right? So there's a lot of details here that I'm not showing. But this tends to be more detailed than what you see in most of the books. So be that as it may. Then we have the concept of data debt. Data debt is the data or information version of technical debt. It's basically bad quality, low quality data when I use the term data debt. So a common metaphor in the data community is comparing data with either oil. People like to say data is the new oil, which means that it's a valuable commodity. Well, water is a far more valuable commodity than oil, and like motor oil, right? And the reason why I say this is I'm more than happy to get together with you in a room, put a glass of water in front of you, put a glass of motor oil in front of you, and I'll sit you out and wait to see what you end up drinking. Bet you it's not going to be the motor oil, right? You need water to survive. You need oil or gasoline. You just need that to get around. It's not quite as important as staying alive, for most people at least. Although some people love their cars, I totally get it. You might want to love your children a little bit more, but that's okay too. So anyways, so here we go. So there's this metaphor in the data quality community that data is the new water. And I recently extended it to go beyond what the data people are comfortable talking about. I'll talk about the extension in a minute. But the idea is this. You pour yourself a glass of water, you go to the tap, you get a glass, you pour yourself a glass of water, and it's filthy. That's a problem, right? So what can you do about that? Well, we could put it in like a Brita water filter, right? So we can have this, one of those water jug filter things, pour it into that, let it, wait a minute or two to let it filter out, and then you've got clean water. That's part of the solution. But if this is your home, well, I've got dirty water coming out of every tap, including the shower, right? So this is a bit of a problem. Nobody would want to shower in water like this. So I could install something a little better, one of those water filter systems, put it in the basement or put it in a closet somewhere, and clean the water for the entire house. So that's better. That's sort of like cleansing data, right? This is data cleansing. I'm trying to use the data, and now it's filthy data coming in from my various sources, so I cleanse it and put it in my AI at this point, right? So this is the level, this is basic data cleansing now. Or I could go upriver, right? Because we're pulling water out of the river to get into my house. Why don't we just go up, and so all my neighbors have this exact same problem, right? So maybe we should be looking at more of a systemic solution. So let's go upriver and see and figure out who's dumping all this filth into our water. So we go upriver and we see, oh, there's this big pipe coming out of a factory and sludge is being poured into the water. So if we put a filter there, suddenly everybody downstream now has clean water. So that's a better solution, right? This would be like doing ETL. So if you're familiar with data warehousing, you extract, load, transform, or that's ELT, or ETL is transform first, then load it. Doesn't matter. But this is the transformation part in data warehousing. So you've got this filth coming in from, filthy data coming in from the data sources. Clean it before you put it into your warehouse. That's still not the solution, of course. Why don't we go into the factory and find out where, because the problem is like filtering at that pipe, it's probably pretty, you've got to change the filters every so often is a problem. There's a maintenance challenge here, right? Why don't we go into the factory and see where the filth is being created to begin with, because maybe we could fix it at that point, or at least filter it at that point and not let it get into the rest of the water, right? Be a little bit smarter about it. So that's the equivalent of maybe putting views in front of a existing legacy database. Or why don't we clean up the actual source? Somewhere in that factory must be a machine that's spewing out garbage. So now, more likely, it's surrounded by filth that it's been spewing out for years. And more than likely, there's something wrong with the machine as well. So we've got to clean up the mess around the machine, because that's still going to get into the water system if we don't. And we've also got to fix the machine. Fix the freaking problem, right? So the traditional data community, they typically go to here, right? They've given up on doing their jobs. Most of them don't even know what their jobs are. They live with filthy data. And they blame the developers, of course, because that must have been them, completely inappropriate. My point is that is what we have to be focusing on. Because the problem is, if we don't, then, if we wait to fix it at the point of usage, if we, wait to fix it when we're putting it into our data warehouses or whatever, we're repeating work that needs to be done, right? Because it's not only cleaning it up for the data warehouse, but all the apps that go after the data source, the legacy data sources, there's going to be cleansing logic in those apps. There's hopefully cleansing logic in those apps, a word like that. Is that cleansing logic accurate? Is it consistent? There's a lot of serious technical debt problems there. Why does this all exist? Because the data folks are screwing around. It's as simple as that. They're screwing around, they're not doing their jobs. So let's start doing our jobs. So anyways, that is part of the vision. Fix your data problems at the source. So just to define data debt, like I said, it's just low quality data. It's technical debt. It's the data aspects of technical debt. Sadly, the technical debt community tends not to talk about data debt very much. Data debt in most organizations is a far bigger problem than code technical debt or architecture technical debt. One challenge, though, I was ranting about that in the question period for the keynote, is that most organizations don't measure this, and when they do, they don't share their data. And this is actually, for those of you who work with the data community, a very interesting observation about my good friends in the data community is they have very little data describing what they do. Now, also to be fair, I can see why they don't bother to measure things, because when I have been involved with measuring what they do, and it's never very pretty for them. So I think inherently, either they don't know to measure, or they do know, but they're afraid to because they don't want to hear the answer. So, but anyways, that's just me. So why does this happen? Well, it's interesting. A lot of data quality problems occur because of project management decisions. Got to be on time and on budget. So what happens? As soon as a team is being forced to be on time and on budget, you cut quality. Almost always cut quality of the database. Developers are a problem, right? Developers will think nothing of creating another database. So in your organizations, particularly like a large organization, you might have customer data stored in 50 places. Is that because of it's a good idea? Was that an architecture decision? No. It was a development team screwing around creating yet another data source, not even remotely understanding the implications of what they just did. But it's very convenient for them, and why do they do it? Well, they got to hit a time and a date, right? Got to be on time or on budget, or you're not going to get your bonus. All that sort of nonsense. And then, of course, you know, we might not have done the job well to begin with. The apps that we build might not be as sophisticated as they need to be. Poor quality data management. Many of you might work in organizations where the data management folks are not the easiest people to work with, and so they get ignored, right? If they have these onerous processes that you have to follow, and you got to hit a date and a time, what do? You blow them off. And you go download some data, you know, some database technology. You start, you know, capturing more customer data in MongoDB or whatever new tool you like. And of course, weak data literacy. People don't understand, like really, like I was talking, you know, earlier I mentioned that creating yet another database is a very serious quality problem. Very serious. How many developers actually understand that? Right, this is news. And to be fair, you can walk them through it and why. But this is news because it's not intuitive that this is a serious data quality problem by creating yet another database. So, there's a lot of reasons why we've got problems here. So what's the implication? What is the implication when, you know, my AI drinks this filthy data? Well, there's the law of GIGO, garbage in, garbage out, right? So what we're getting at in this slide, so this is from the K2 View, our data readiness study from about 6 months ago. So I'm hoping that we'll start seeing updated data out of them soon. So this is a fairly decent source, but some of the challenges being faced by GenAI, roughly half of teams talked about data consistency, data quality and data consistency as a challenge for them. Another study, and this is just 2 studies of many, but another study we're seeing, so this study from Scale Zeitgeist, they were asking questions along the lines of what's holding you back. They're more of an AI, they're an AI company, right? So what's holding you back, corporate people or government people, from doing AI? And the third, from this question, what's stopping you at your company, data quality was number 3. And over here, if you haven't yet adopted AI, why not? Data security and data concerns were number 1. So this is, there's some challenges here. Now, the issue becomes, well, what are you going to do? If data quality is a problem, and if it's a serious problem for a lot of organizations, what are you going to do about it? Let's keep that in mind. So the question becomes, is in the life cycle, this project-based life cycle I showed earlier, where could data quality probably affect us? Well, obviously, when we're looking into the data itself, what data do we think we might need to build this AI? Well, data quality is going to come and bite us. When we're doing data cleansing, data preparation, of course. When we're training the model, garbage in, garbage out. When we're testing, because when you build an AI, you get your you've got your data, whatever you believe you're going to build, and then you split it, right? You've got your training data set, like 70 or 80% of your data. Then you've got your test data set, which you validate. Does the AI answer the questions right? Does it predict? Does it have a high level of? Does it have accurate predictions? AIs are basically prediction engines. So an LLM predicts the next token, predicts the next word, the next letter, the next word, the next part of the image. That's what's going on there, right? And obviously other types of AI is a little more obvious. But, and then of course the production information that we use, if we have poor quality data out there in the wild as we're running our AI, got a problem there. And then the data that we're generating, any learnings coming back from operations, also potential for data quality problems there. So there's some fragility here, is the way of looking at it. So what types of data quality problems might you run into? Now, this is just a very high-level list. So data quality problems in general, but some of the interesting things that are reasonably specific to AI, biased data. You've probably heard that one of the challenges in AI is bias, right? I don't mean to burst anybody's bubble. All data is biased, guaranteed. Right? It's just how biased is it is the issue, and can you reduce the bias? But you'll never reduce it to 0, because the problem is the data is generated by business processes. There's bias in your business processes or in the business processes of whatever it is that's generating the big data coming in from external sources, right, which are out of your control now, roughly out of your control. The business processes are run by humans. Humans are inherently biased. Regardless of how wonderful you think you are and how wonderful your mommy has told you are and all this good sort of stuff, you're biased. So biased people are running biased business processes, creating biased data. There's a wonderful book by Kathy O'Neill. She's written several wonderful books. The book that I find the most wonderful by her is called Weapons of Math Destruction. And it's basically a collection of data horror stories it's all like every chapter is a case study of some freaking disaster that occurred because of data or because of AI. And it's always a horrible story. But the interesting thing is all the stories are, here's this group of well-intentioned people trying to make the world a better place by some cool data science thing or some cool AI thing. And then here's the shit show that happened, right? People went to jail in some cases. People got killed in some cases. People, their financial lives were messed up, if not destroyed, in some cases. Imagine having to go to a bank to get a mortgage. You get your young family, kids on the way, you want to get a house. So you go and you apply for a mortgage. The bank AI system turns you down for whatever reasons. Maybe good reasons, maybe bad reasons. That's devastating for you. Imagine being, I'm sure some of you, at some point you were young families, right? You went through this, or maybe you're going through this now. So like simple thing, but from the bank point of view, they want to be financially responsible, they only give loans to the right people and all that good sort of stuff, right? So well-intentioned stuff with some very interesting societal consequences that get exasperated by AI or by data science, depending on that was an AI problem. But anyways, so stuff happens. So you got to be very, very, very careful about what inherent biases are in your existing data, because the only thing that will happen is your AI will be even more biased as a result. And it'll be biased at internet scale and internet speed. So be smart about that. And then some basic things. You might not have the data you need. You might have missing data. This was actually, I looked into this issue for my thesis. This can be a devastating thing depending on the model. Like absolutely devastating depending on the model, your type of model you're trying to create. Or sometimes it's like, who cares? It was very interesting. Weird stuff. Yeah, that's what happens when you do research. Weird stuff happens. Who owns the data? Here's something that the developers often don't understand. Semantic differences across data sources. So I've got a table. So say we're an ice cream company, and we've got one database over here with 30 wonderful flavors, and I've got another database for the Bangalore or the India ice cream company, and it has its flavors, and they're different flavors. So how the heck do I combine that data? Or the Americans have 7 different versions of chocolate, but the Indians only have 1. And the Indian chocolate flavor is not even close to any of the 7 chocolate flavors if you're like a chocolate sommelier, whatever the equivalent of a chocolate sommelier would be, right? So semantically, those are different things. But we're trying to, now we're trying to compare and roll it up. It's a disaster, right? Looks the same on the surface. Everything looks the same. Chocolate's chocolate, right? But for those of you who know what chocolate is, that's not reality. Talk to my wife. Believe me, she can tell you everything there is to know about chocolate. We have data poisoning. We have either companies or organizations purposely creating false data to mess us up. We're all familiar with all the political disinformation and all that sort of nonsense. Well, that disinformation is out there on the web now, and the AIs are sucking it in. So think about that. We also have data poisoning just from the stuff that's being generated by AI. It's a big problem now that the LLM companies have is there's all these people who are writing blogs using AIs to help them write the blog, and in some cases completely write the blog. So you get this really low-end information being spewed out, and then now that's being ingested by the AIs for their next models. So the quality of the data that they're ingesting is going down, and this is measurably so. That's a problem. Another problem called data drift. Oh, there we go. I'll go back one. There's this concept called data drift. So why is this feedback important? This feedback cycle important? It's because at the point in time that I deploy a model, it reflects reality. So if I deploy a model right now, and so my training run is going, model gets deployed, right? So the model is up to date as of 11 a.m. Thursday morning. But reality, the world is still running, right? So now things are changing out there in reality, and my model, because it only reflects up until 11 o'clock on Thursday morning, is now out of date. So reality is actually drifting away from the model, so I need to update the model, right? So we say this is data drift. What it really is reality drift. But it's harder to convince people that that's the problem. So just to sort of start to wrap up here, so how do you know what data quality techniques you should choose to help address your data quality challenges? Well, the quick answer is it depends. So the good news is that there are a lot of different data quality techniques, and this is 10%, right? This is some of the more popular ones, but this is just a small number of techniques that you might want to choose to adopt to potentially improve your data quality problems. So that's okay, or avoid data quality problems, even better. So the question is, if this is our life cycle, and here's how data is being ingested at different points in time in the life cycle, what are the implications of that? Well, so it depends, depending on what we do. So the data quality problems that I will experience here are different than the data quality problems I need to address here. I'll need different types of techniques to address this data quality crapola as opposed to this data quality problem, right, at a very high level. So what's the implication here? So how do we know the context? How do we start judging? So I like to look at 5 factors. These are ranked scales. The situation on the right is better than the situation left. So I want my answers to be as right as possible. So timeliness. When am I applying this technique? Am I reacting to a data quality problem? Oh, look, bad data. Or am I trying to avoid data quality problems to begin with? Am I being proactive about this? How well can I automate this technique? Absolutely critical, particularly from a techie point of view, right? If I have to have people involved in quality techniques, that's generally bad news. What's the effect on the actual source? Am I directly fixing the problem, and I'm going back into the factory and fixing the machine? Or am I filtering my water at the tap, right? So that sort of a thing. How long does it take me to realize the benefits? What's my payback period? Because this is critical. Most of the traditional techniques have multi-year payback periods. This is why they fail. Organizations can't stay focused long enough to allow their data quality techniques to work for them. Management being what they are. And finally, how easy is it to pick up the skills to do the techniques, right? So there's a bunch of issues to look at. So how would we rank data cleansing at the point of use? This is what the data scientists are all complaining about. They spend all their time doing data prep and data cleansing, all this sort of stuff. Well, why is this not a great way of working? Well, it's a reactive technique. You know, I'm fixing a data quality problem as it's coming in, just before I'm about to use the data. Luckily, I can automate a lot of this, and there's a lot of great tooling, so that's not bad. We're not fixing the source, so I'm just throwing money away. This is a stupid thing to be doing, actually. That's my big issue with data cleansing. It's immediate, we get the job done, which is why they're doing it, because more than likely the people who own the source are hard to work with and don't have the skills and all that sort of stuff. And it's a mid-level skill. Not so bad. Here's another technique, database refactoring. This is something I pioneered about 20 some odd years ago. Well, also mostly reactive. Unfortunately, not as automatable as I like, because humans are involved in this. Right? You gotta figure out, oh yeah, there's a problem there. Oh yeah, I gotta fix it. Do the work, and then the rest, the actual work is automatable from there. Directly affects the source. That's good news. Benefit is immediate. That's good news. And doesn't require a lot of skill anymore. There's a lot of good tooling and all this stuff. It's reasonably straightforward. Still requires some skill, but not so bad. So, if for just two of those 5 comparison factors, we see database refactoring. So if these factors are important to us, based on our situation, database refactoring is a pretty good idea, and data cleansing, and not so much. A few other techniques from that previous slide, 4 or 5 ago, well, they're clustered there. Now, I have a detailed page, or sets of pages actually, comparing these techniques with all 10 combinations of the 5 factors. So the way you read these charts is generally the techniques in the green box, the top right corner, are far more attractive than the ones in the bottom left corner for those 2 factors, 2 of the 5 factors. So depending on your situation, you identify the factors that are important to you, then based on whatever the factors are important to you, that gives you insight into what techniques to choose. So let's do another example, going back to lifecycle. So how do we choose the factors? Well, if I'm worrying about the issue of bringing internal data in to envisioning, or data into envisioning, then the two factors that are most critical are timeliness. I want to be because I'm in a reactive situation, and the benefit. I need to immediately fix this data, or darn close to that. If I'm just trying to fix an internal data source, then this is what I'm looking for. If I'm dealing with data coming into either construction or inference, those are the issues that are most critical to me. And same thing for up there. Different contexts of where I am in the life cycle drive different give me different priorities, which means I'm going to choose different techniques based on the priorities, based on the context of the situation I'm currently in right now at 11:30 in the morning. So when we look at, well, what techniques would I do to fix in an internal data source? Well, these are the two factors that I'm most concerned with. But if I just blindly look at this chart, then it tells me, well, if I adopt some of those techniques there, I'm probably okay. But I know. 2 or 3 more slides, I'm good. The challenge is that some of those techniques aren't applicable to that exact situation. So what I got to do is really have enough skills to know, oh, wait a minute, I'm fixing an internal database, fixing the source data or database refactoring is good. Applying business rules is not the way to go, right? It just doesn't make sense in that situation. So it depends. And it was interesting, when I started working on this a few years ago now, I was desperately hoping maybe I could have prescriptive advice here. And then it didn't play out that way. But there's still good advice. So one last example before we wrap up. Same sort of thing. So here I am looking at things up there. Well, those two techniques aren't going to get the job done. Those two could. But you know what? Oops. Those techniques are pretty good too. So the idea is that I would first try to do this, one or both of those. If it works out for him, if it does, great, it worked. Good to go. If for whatever reason that's not going to work in my environment, more than likely those techniques, or maybe some of these down here, would work. Desperately would want to avoid all of this. So that's because more than likely they're not going to get the job done for my situation. So just to wrap up here, the main messages I want to get across, data quality is absolutely critical. If you don't have good data, you will not be able to build a good AI. End of story. End of story. Nothing you can do about that. The best place to address data quality is at the source. Fix the source. Everything else, and think about the water metaphor. Fixing your cup of water is not the way to go. You want to really stop polluting the environment. And the challenges that you face, your context, will drive your choice of multiple data quality techniques. One size does not fit all. One technique does not get the job done, regardless of what the vendors want to tell you. Everybody's got a magical tool they want to sell you. And yeah, it's probably a great tool that solves a certain class of problems. Great. But that certain class of problems will not be all of the problems that I solve. So anyway, so thank you very much. I guess I'm totally out. Can I do questions? No. No. Okay, I'm good. So I'm going to be around. Can I take one question, or do you need to kick me out?